Audible, no problem.
Okay, great. So let us start with this first topic, which is introduction to AI. We have 40 minutes, so I will start right away. However, if you have any questions in between, please feel free to ask. You can either unmute yourself and ask, or ask in the chat window. If you're asking in chat window, please raise your hand also. There is a gesture here to raise your hand. Please do that so that I would know that you have asked a question and I can take the question immediately. So we'll go ahead. So we are looking at what is AI, and this term is being used quite often nowadays. And people have different definitions of AI. But I think the simplest definition I would like to say is, it's just that intelligence demonstrated by machines, unlike natural intelligence displayed by humans and animals. So when we talk about human intelligence, we have some thought process, something which is different than human animal intelligence, like the intelligence shown by dogs or intelligence shown by monkeys. Similarly, your intelligence demonstrated by machines. Okay, so it's not same as human intelligence, or it is not same as natural intelligence. I guess many times people talk about AI as if there's a human who's, we are comparing human intelligence. That may not be the case. Yes, there is intelligence there, but it need not be compared with human intelligence. We could also call it a machine's ability to perform some cognitive functions, which visually associated with human mind. Say, let us say talk about vision. So computer vision is one of the field in AI. So computer can see, computer can hear, computer can speak, right? So machine can do all of that, which generally we associate with human minds. So that is the one. But I guess the latest focus of AI, or is, that instead of looking at what AI can do, is that how it extends human capability by sensing, comprehending, acting, learning, and creating. So we'll talk more about it as we go along when you talk about future of work with AI in the third session. But our focus of AI is not to see AI as something which is different, and this is something which is something very complicated, but something which we could use to make ourselves a little better. So we will talk obviously more about that in our third session, but I'm just putting this definition just to say that, it's all about how we can augment or add to the human capability. Obviously, we'll see more about AI as we go along, but let us see where did it begin. And many people think that is a very latest field, very latest trend per se, but it is not that latest. As a matter of fact, this term was first used in 1955 by John McCarthy, who is also considered to be a father of AI. But even before him, Alan Turing talked about machine intelligence per se. He didn't use the term artificial intelligence, but he talked about Turing test, which is very famous. And in 1952, a game was developed which was more like looking like AI. So these were the days in 50s where the people are thinking about, what could be AI and those kind of a thing. But in later it started the movement. In 58, there's a programming language which was created specifically for developing AI application. Just like we have heard of Java or Python, you might have heard of those languages. LISP, that is list processing, is a language which was created specifically for, we call it the AI programming language, and it was created as back as 1958. The term machine learning, which is also used quite often, which is a subset of AI, and we'll talk about it a little more, was also coined in 1959. So people already started working on those concepts essentially in that at that point of time. Uh, the one of the form of AI which we are kind of aware is a robot. A robot is something which can work on its own, and there are two types of robots we could talk about generally. We say industrial robot, which will be used in factories, and then we talk about humanoid robots, which I'm sure you must have seen some pictures. A robo just like looks like a human, but industrial robot have been started working as early as 1961 in General Motors in New Jersey, and that was the first industrial robot called as the Unimate, which had started. In 1965, there was an expert system, which was the first technology. So we talk about machine learning and deep learning as we go along. But the first popular technique of achieving artificial intelligence or machine intelligence per se was in 1965. when they developed something called the expert system. And the idea was, how machine can think like expert, or how it can make decisions like an expert. And this was really a good experiment in itself. And it was done in 1965. Then obviously this software came in commercial world, and there was some development. However, the way AI progressed is that there have been ups and downs in AI. And we also use the word AI winter, which what it means is that at some point of time, AI was seen as something which is, very exciting field. A lot of people are interested, and a lot of funding was involved, and so on. And later, people realized that it doesn't do all that what we think it does. And people lost interest. So generally, what happens? You expect a lot from a particular technology, and the technology always has some limitations. It's not something that is unlimited. And then you expect more, and then you get disappointed, you get disillusioned, and then you kind of drop out of that. And that is what happened with AI multiple times, not only once but multiple times. And in 60s, 70s, and 80s, there were times when there was not much interest in AI, there was not much research going on in AI, and so on. So there were times where people said that no, this seems interesting, but not, it's not going to do as what it is. So that is to happen. I mean, one of the thing, for example, I would give is earlier there was a lot of interest in translation by machine translation. During Cold War, US was very interested in translating Russian messages using machine, and they found early successes. They could see that machine can translate quite well, and there was a lot of interest. A lot more research was done to develop this technology, and later they realized that there is a limit on how well it could do. And then there is a disappointment, disillusionment, and the funding dried. I mean, today also we see our Google Translate, or even Chat GPT Translate, and you find it does a very good job. Okay, but then you also expect more, and you think like it can do as good as humans by taking into account all kind of aspects of language. And yeah, you find sometimes it's not doing that great, and maybe you will get disillusioned saying that, oh, we thought this will do so good, but it didn't do that much good. So that kind of disappointment, disillusionment is always possible. So it's important to note that AI is a great technology. It's definitely a revolutionary technology, but it has its own limitations, and the limitations are going away as we see as it progress from 50s onward. So in 97, interesting thing happened. IBM developed a software called Deep Blue, and it beat Gary Kasparov, which was the world chess champion at that point of time. And that was a really great moment because that's the first time that chess is considered to be a brilliant game and it's an intelligent game. And Gary Kasparov was the world chess champion. So it was like the best of the best human, and the software could beat it in this game. And that was a great moment at that point of time. So a lot of people actually saw the potential of AI at that point of time, but many more people saw it later in 2000s. And this is an interesting graph that I want to kind of show it to you. It shows the error rate. So there's an ImageNet large scale visual recognition challenge. This is runs every year. And what it is shows that they show images, and this machine should be able to recognize image. And some error rate is calculated, how well it could do it. So maybe if it's a 25% error rate, means out of 100 images, it could recognize 75 correctly, 25 incorrectly. Obviously, when we're looking at humans also don't have perfection, right? So humans, the typical benchmark is 5%. That a human, if images are shown, 100 images are shown to a human, maybe 95 images can be recognized by human may make a mistake in say 5 images. So human error rate is 5%. So in 2010 and all that, the error rate was as high as 27, 28, which obviously was dropping over a period of time. In 2012, it dropped considerably. If you say 2012 dropped considerably. The reason it dropped considerably because we started using something as a deep learning, which we'll talk about a little later. And the deep learning is kind of got attention. A lot of people saying that, oh, this seems to be interesting. It's kind of 16% error rate. And next year, more and more models are coming with deep learning technology. So, expert system, machine learning are basically technologies, the techniques of AI, using which you can achieve machine intelligence. And with deep learning, we could see there's a considerable decline in the error rate. And next year it became even lesser, around 12%. And then in 2014 it become 6-7%. And then in 2015 and onwards, actually it started going below 5%, which is human error rate, which essentially means that when it comes to image recognition, machines can do better uh, than humans. I mean, an average human, obviously, but machines can do much better than humans. That is what we can say as an AI moment. Because a lot of people said that this is where we are kind of breaking the barrier. So earlier AI was always there, but this is the first time we could say that we could see that it could perform better than humans when it comes to image recognition, which was supposedly a task which is more associated with human cognition, right? So that people thought as an AI moment. For some other people, AI moment came when they started using ChatGPT. So when ChatGPT was launched in November 22, uh, that was the AI moment. A lot of people actually started working with it and get amazed to see the kind of output ChatGPT makes. So it can write poems, it can answer your questions, it can brainstorm with you, it can discuss with you, and so on and so forth. And that was also seen as an AI moment. So just one. So obviously it raises a lot of expectations, as I said, and whenever expectations are raised, they're also worried about, are the expectations are justified or are too unrealistic expectations are being done. So what AI researchers have done is that they have kind of said, let us look at the types of AI and let us define how the AI can be classified as based on capabilities and as based on functionality. And this is what it is. So on based on capabilities, we could classify AI in three parts: narrow AI, AGI, which is also called the broad AI, or artificial general intelligence. AGI stands for artificial general intelligence, and then super AI. And narrow AI is something which we said, that the AI system or the AI agent, if you can call them, are the ones we can do only one thing at a time. Okay, or rather, they can do only one thing. So if you develop an AI system or AI agent, that's a term which is typically used, develop an AI agent to say approve loans. So if there are loan applications, and if you develop an AI agent to approve loans, and you develop this model or this AI agent to approve loans in India, okay, with a lot of data which is fed in, then that model, that agent will work for loan approval in India. We can't expect it to do approval of insurance policies or insurance applications, or we can't even expect it to do approval of loans in USA, because it is developed for a specific purpose or a narrow purpose, and that is what it will do. It will not be able to do other things. It will not be able to learn and do something related field, right? So it is trained on something very specific. And that is what we say narrow AI. It could be also something like it could recognize handwriting. Okay? So that is what it will do. It will not do anything else, right? So it's a narrow AI. And incidentally, that is what kind of AI which is available today. So all that AI that we have, all the systems that we see, AI systems, are focused on doing something, one thing very specifically. Even if we talk about ChatGPT, what it is good at is generate text. That's all. It doesn't do anything more than that, right? So every the capability is kind of narrow. It can't do multiple things. It can do only one thing at a time. The second one, which is called artificial general intelligence, which is the term which is used, also broad AI, is something where we say it will become like a human, where humans can are trained on one thing. They can also learn to do something similar. Now that is something will be AGI. So it's very similar to human intelligence in a way in capabilities. Incidentally, this is not yet in action. When AGI, the work has been doing on, there's a lot of work going on, a lot of research is going on in AGI. But as of now, AGI doesn't exist. It's a concept. It's a theoretical concept. It is not in practice yet. But we have researcher has given a name to it, saying it's a AGI, and this is something that could happen. But right now, whatever AI we see is narrow AI, which essentially means that is not anywhere comparable to human intelligence. What we could develop, which is comparable to human intelligence, is AGI, which is artificial general intelligence, which is a theoretical concept as of now. The third type is what we call the super AI, which is what we'll say superhuman capability, right? Something that humans can't also do. Something like that if you could develop. Needless to say, this is also a theoretical concept and it is not yet achieved. So the research is going on, and eventually we may reach a point where we could have AGI and we may have super AI. But as of now, regardless of whatever people think of AI, the capabilities, the matter of fact is that it is still, uh, narrow AI. It is still something which is very narrow in its capabilities and not something like general intelligence. If you look at functionality wise, then there are again four types. The first two types is what are real, that is reactive machine AI and limited memory AI. Reactive machine AI is something what we use for loan approval systems or doing some predictions. What you see movie recommendations by Netflix and all that is largely reactive machine AI. Limited memory AI, on the other hand, is where the system will also remember things. So when you talk to ChatGPT, for example, it remembers the interaction with you. So if you use ChatGPT more often, it will do better and better job. Similarly, if you talk to Alexa more often, then Alexa will understand you better and can accordingly make uh, you talk accordingly well. So you kind of develop kind of a good memory, it develops a good memory of what you are, and it accordingly improves. If you talk about driverless cars or self-driving car, the similar uh, concept is used, similar AI is used, where it remembers and learns from it. So both these are real. Okay, limited memory AI is obviously more powerful than reactive machine AI, but both types of AI are very much in use. The third one, which is called theory of mind AI, is something again a theoretical concept which relates to AGI, where we say that it will functionality wise it is same as a human mind. So just like we talk about human mind, how it thinks, and there are emotions that what we have. Maybe the AI will also have emotions going forward, and it can understand others' emotions, or rather, not it have emotions, but it will understand others' emotion. So today, Alexa can hear you, but it hears you as a text, and then I mean, rather, it hears you, converts into text, prepares a response in text, and then speaks out. It doesn't really capture the emotions as such, but a theory of mind AI is something which will capture the emotion, will understand emotions. So this is again a theoretical concept, and which is related to HEI. So once that happens, then we'll have agents which can understand emotions. Right now, it doesn't. Okay. And then the fourth, which obviously is again theoretical concept, was self-aware AI, which is where the AI agent will not only understand emotions of others, but also understand one own's emotions, which is like a superhuman kind of capability, superhuman kind of capabilities, and that is what we talk about as a self-aware AI. So reactive machine AI and limited memory AI are something which we say real. The other two are more theoretical. But the reason we are defining these types is largely because to manage the expectations of people. So when you talk about AI, what AI can do, as of now, what AI can do is narrow AI, or what AI can do is functionality wise is reactive machine AI and limited memory AI. What people think AI could do is what is AGI, which is a artificial general intelligence, or sometimes people think is a super AI. But these are concepts, and they are defined so that people can understand this and say, okay, this is not what is done yet. Huh? So let me take a pause at this point of time and see if there are any questions. Okay, so let us proceed to the next topic, and this is the terms which we hear. So I talk about expert systems, but that is not. I mean, they are still used in some parts of the world, but not so much. But what is nowadays talked a lot about is machine learning, deep learning, and generative AI, which is what we talk about ChatGPT or Gemini from Google, or Copilot from Microsoft. So these are all Gen AI. So, but if you look at it, how these terms are related, and people may kind of get confused. So just to clear the confusion, artificial intelligence is a big field which contains machine learning. So machine learning is a subset of AI. Deep learning is also a subset of machine learning. So machine learning involves training a machine using a lot of data. So basically what we are talking here is that there could be a lot of data possible available. So for example, loan approval system, we don't know how loan approval system should must be working. But what we have a lot of data about all past loans, and we could actually fill in, use that data to train a machine. So that is what a machine learning is all about. When we use something called the artificial neural network for doing it, then it's called deep learning. So that comes as a subset of machine learning, and a specific types of deep learning, specific types of neural network, the way they are used, result into generative AI. So the takeaway from this slide is that these terms are related in such a way that Gen AI is a subset of deep learning is a subset of machine learning, and machine learning is a subset of AI. Let us understand these terms a little more. So when you talk about machine learning, we talk about four types of machine learning. One is supervised machine learning, which is where we will predict, and there are several types in terms of what we will predict. So let us say we are predicting whether it will rain or not. Then we say it's a classification problem. When in email inbox you see something as a spam filter, that's also supervised learning. And it's a classification problem because it will say whether it is spam or not spam. So that is what we are predicting. So that's a predict category classification. Regression, on other hand, will predict numeric value. So how much will be temperature tomorrow? That is the prediction that we are doing. That's a numeric value. Or what will be the sales next year is a regression problem. We are predicting the numeric value. So supervised learning essentially means we have a data, and what we call is labeled data, that we have what are the input variables, and we also have an output variable, what it has been in past. So we, for example, have a loan approval uh, database where we have all that details we captured in loans, and then we have one output variable which is loan approved or not. So that is the output variable. Using this data, we train, and then it can predict whether we should approve it or not. And that is a classification problem. So supervised learning means we give data to machine with output that we are seeing was called label data, and then the machine learns from it, and then it can start predicting that output for the new data. So that is what we call supervised learning. We're supervising it. Unsupervised learning, there is no output variable. We just give data. And then what machine can do is something like organize similar item into groups. So it could do clustering. So for example, if you're talking about credit card transactions, so there are many attributes of transactions, where it has happened, when it has happened, what is the amount, and so on. And you could actually give this data to machine, and machine can actually do clustering. It can actually cluster transactions. And there could be transactions which don't fit in one of these. That's because of anomaly. It's something which is different. And that could be a fraud, or it could be something which is unusual, which need to be investigated. Right? So clustering is a very popular technique which is used. Another is association analysis. Like for example, if you go to a supermarket, you will see people buy eggs, bread, milk together. Why do they do that? Because these are all breakfast items. So people will buy these things together. So there are many such items which are brought together. And if you want to really find out which are these two or three items which are brought together by people, then we could do what is called association analysis. So there is no output variable per se, but nevertheless, it could give some insights which are very useful to us. Then comes reinforcement learning, which is very similar to what the way we train dogs. So the way we train dogs is that we'll reward dog if he does a good job, and we'll punish dog if he doesn't do what has been told to him. So it will reinforce it. So if it does something good, it will get a reward. If it doesn't do correct thing, it will get punishment. So similarly, we train the machine, and this is largely used in development of models or agents which were in the play in games. So for example, if you're training some machine for learning chess, if it does a good move, it will be rewarded. It will be told that it does a good job, and if it is not, then it will be punished. And it will learn what works well and what doesn't work well, and accordingly it will learn. So that is called the reinforcement learning. And this is self-supervised learning. So the challenge with supervised learning is that we have to create the data, right, in particular format. But we could always give some data, which is the machine itself can find out what are the labels. So this is used in a training of Chat GPT. So in Chat GPT, we talked about training Chat GPT is big task. So how it was trained? It was trained on all the text that was available on internet, like from Wikipedia or New York Times and all that. And how it was done? It was kind of told that this is the text, and you need to predict the next word possible. And it could figure out that this is a, so you read a sentence, it will start with first word, it try to predict the second word, and then it will predict, and then it will be given the second word, and then it will say, okay, this is what correctly done, then it is great. If it is not, it will go ahead and improve. And the way it was done, the text was fed at once, so there was no humans who's feeding, making this labeling. The labeling was itself done by the machine. So that is what we call a self-supervised learning. So there are four types of learning. Obviously, there are a lot of detailing in this, which will not get into in this introductory level workshop or introductory level webinar. But each one of it has its own body of knowledge in terms of what algorithms we could use and how could we use, how could we compare, and so on and so forth. But I guess you get an idea of what is machine learning as a whole. Deep learning, as we said, is a subset of it, and it makes use of neural network. So neural network is what we have in our brain. So our brain has neurons that are connected to each other, and that is how our brain functions. That when we learn something, there are more connections happening between these neurons. Okay, we call it the firing of neurons essentially. So as you are hearing me, there are neurons being formed, not neurons being formed, but the connections are being formed in your brain, and that is how you are learning, right? So the same thought process was used or mimicked rather in artificially in software. So the neuron here is like basically a software function, or mathematically we can use as a mathematical function, and then you can organize these neurons in a particular way, and that is how this deep learning could happen. Obviously, when it all started, it started with a simple neural network called as a multi-layer perceptron, and it was used for image classification, text analysis, regression problems, and so on. Then came newer types of neural networks, like convolutional neural networks, and this was used for image recognition and image processing. This is CNN is what is called. And then came RNN, recurrent neural networks, which was used for speech recognition and language processing. Then there is a variant of it which is called long short-term memory, LTSM, which is used for language modeling per se. And then came GAN, which is generative adversarial networks, and then came transformer, which is what we generally use for natural language generation. So this is what is used in GPTs, Chat GPT, or Gemini kind of a thing. Again, there's a lot more in each of these models. We'll not be able to get in it in detail, but this is what to give an idea that there are so many learning models there. Yes, Vinay. So we'll talk about it more of how it is being used in business in next session. So I just thought we'll set up a theory understanding of this now. And there are tools in a sense. If you look at Chat GPT is a tool which is used for generative AI. That is what we use. We were not using many of these techniques because they are used internally. So we'll see what kind of examples in the next session. We'll to talk about how these are being used. So tools, something that we'll discuss, or how they are being used, we'll discuss in the next session. Yeah, but this is what is happening under the hood, or we say behind the scenes. Okay, so just want to give a glimpse of it, and you might hear this term, so you should be kind of aware that this is what it really means. Okay, so Gen AI, which is what is used to generate text, video, images, and data. So examples of this is chatbots. I talked about ChatGPT, Copilot, Gemini, or Llama. But there are also text to image AI generation. So you give a prompt, Say that I want to give me an image of an astronaut riding a horse, and it will create an image which is generated. It is not there. It is not copied from anywhere. What prompt you give, it will generate an image. So that is what there are software like Stable Diffusion, DALL-E, and all that. And now there are video generator also, like Sora, which is what OpenAI has come with, and it will develop a video. So that you see as not as what you can say very sophisticated video, but if you look at a small video clip nowadays, a lot of people start using those video clips. You will see that they are being used. They're using this tool is called Sora. So that's one which is widely used. So the companies which are there in this space is OpenAI, which has developed ChatGPT and Sora. And then Anthropic is there. Microsoft is there. Microsoft has got Copilot. Google, which has got Gemini, and there is Baidu, which is a Chinese company. So they also developed this generative AI model. Right? So this is what I thought I have. Now let me open this session for question and answer. If you have any questions, please free to ask, or if you want me to elaborate on something more, we have 7 minutes to go. So if you have any any doubts or questions you have, please feel free to ask now. Yes, the question is data security is my concern. Yes, data security is a concern because we'll talk about this. I guess what you mean largely is data privacy. I mean, your data is being used by these models to develop this kind of learning or insights. So I guess that could be a concern, and that's a concern people are expressing. So one of the limitations of AI or the concerns of AI is that it requires uh, data privacy, which violates uh, data privacy of people. So whenever you are talking to ChatGPT, and they mention it, I mean, it's not something which is hidden, but they mention is that all that is used for training. So when they learn about you, they're also, so when you're talking about it to ChatGPT, it is using your data, it is transferring your data to their servers, and it is used for further training. Hopefully it is not misused, but people do talk about the risk that what if somebody hacks into ChatGPT server and gets all that data, right? And then they can misuse. So maybe OpenAI, which developed ChatGPT, may not misuse our data, but what if somebody hacks into their system and gets data which is mapped to your user ID? Then that would be a big problem, right? So private data privacy is a big concern, right? So we have to be very careful. So for example, for example, I can use ChatGPT to get me personal finance advice. So I can actually ask ChatGPT, the difference between equity and debt, and what is more preferred, whether I should put an equity, or what is the benefit of index funds, and so on. But I should not be sharing my bank account details. I should not be sharing my how much balance I have, and so on, because that's a private data. So we should be careful about that. When we use any other online service, that is Google or Facebook and all that, you should also have those privacy controls that we should use. So that is definitely important. Uh, how the data privacy should be protected in the age of AI. Yes. Does that answer your question, Vinay? Okay. Is there any other question or any doubt, or do you want me to elaborate on a particular point? Okay, great. So we have 4 minutes, but if there are no questions, then we can even close this session. We'll meet again at 11, and that is where we'll actually talk about how AI could be used in business. And we'll see different applications, possibilities of business. So I have actually only 3 slides, but I'll talk a lot about it. And I will also request your inputs in terms of how you use seen AI being used, or if you're involved in AI, then how you have found AI being used. So we could have more of a discussion session to certain extent. And the third session that we have is actually more for discussion in terms of what is the future of work with AI, how it will develop. And I again have a few slides there, but that will be more of a discussion session. We'll discuss how, and I like to hear your thoughts about how AI could be useful. So this session was largely about setting the context, setting what it is AI, and we talked about a lot of jargon, all these CNN and RNN and all that, but just to set the context. But we'll now get into more discussion about applications of AI and future of AI. So if there are no questions, we can close this session now and let us meet again after 20-25 minutes, after 20 minutes in the second session at 11 o'clock. Let me stop the session now. Thank you very much and see you again at 11.